Hello, thank you so much for tuning into my YouTube channel. Today's video is going to be a tutorial on predicting digital camera color quality. Let's get started. As I said in this video, I want to talk about predicting camera color quality. Color quality can be measured in two ways. The first is target-based, where color difference statistics are reported comparing image data with measurement-based colorimetric data. You can find out more about this process and how you can do it in one of my former videos shown here. The bigger the color difference, the worse the colorimetric performance of the camera will be. But this is a long process, as we have to colorimetrically characterize the camera, which consists of a few stages, and if you see the video you will see how long the process is. But what if we want to measure the camera's ability to reproduce true colors without going through that process? Is there any way for that? In that case, we can use mu factor, a factor defined as follows, where A represents the color matching functions of the standard colorimetric observer and S is the spectral sensitivity of the camera and trace denotes the sum of the diagonal elements of a matrix. Therefore, to use this equation, we first need to have the spectral sensitivity of the camera. The closer the value of the mu factor to 1, the more accurate the color reproduction of the camera. A mu factor of unity means the camera records color identically to a standard observer, which is perfect. Using this method, we don't need any target and we don't need to go through the long process of colorimetric characterization as explained in my former video. In this video, I will use 4 cameras to show you how this equation works and how it can help us predict the camera color reproduction ability. The 4 cameras are Canon, Hasselblad, Nikon, and Sony, shown as follows. Here are their spectral sensitivities. As you can see, Canon, Hasselblad, Nikon, and Sony. Now we're going to use these spectral sensitivities and predict the camera color quality. Let's go to MATLAB and see how we can apply the mu factor. So this is the program, as you can see here. First I'm going to need access to this file, and this is where it's located. That's why I'm going to add path to that location. This is the file that contains the color matching functions of the standard observer. And this is the file that contains the spectral sensitivities of the cameras, and it's right here. Canon, Hasselblad, Nikon, and Sony. These are the spectral sensitivities of these cameras from 400 to 720 nanometers at 10 nanometer interval. And I'm going to assign the color matching functions to matrix A and assign the spectral sensitivity of the camera to S. And this is where I'm going to be calculating the mu factor, and then I'm going to be displaying the result. And don't worry, you could have access to this code using the link in the description section of this video. Okay, let's start with the first camera, which is Canon. I'm just going to put it here in this sensitivity, and then I'm going to run it. So the mu factor for Canon is 0.9. The second camera is Hasselblad. Copy it, and then paste it here, and then run it. It's 0.8. The third camera, which is Nikon, I'm going to put it here, and then run it. It's 0.9 again, it's not bad. And then Sony, I'm gonna put it here and just run it. It's 0.8, it's almost 0.9. So as you can see, the second camera, which is Hasselblad, has a very bad color reproduction because its mu factor is 0.8. But the first, third, and the last one, which are Canon, Nikon, and Sony, they have a good color reproduction because it's 0.9. And it's much higher than 0.82, which is for Hasselblad. And that's about it. This is a very simple factor using which you could predict the camera color quality. Thank you so much for watching this video. I hope you liked it and you were able to get something out of it. If you liked it, I would appreciate it if you could subscribe to my channel and also share the video with your friends. Thank you so much and have a nice day.